Good evening, everybody. So, as we have seen yesterday, centripetal acceleration, tangential acceleration, net acceleration, and many new things we have discussed in yesterday's class. So, now today's class, we are going to continue from there. So, as we know, linear motion and as well as angular motion or rotational motion. So, different terms are there. So, we used to study in class 9th equations of motion under uniform acceleration. So, till now, what have you studied in 9th class? It is all the equations, all the three equations of motion, even four if you have studied also. So the equations of motion under uniform acceleration. So R means the acceleration is remains what, everybody? Acceleration is remains constant. So we have studied three equations. That is what equation number 1, V is equals to U plus AT. Second equation is what? S is equals to UT plus
half AT square.
Yeah. So S is equals to, S means what? Distance or displacement. S is equals to UT plus half AT square. And final one, V square is equals to U square plus 2AS. So these are the three equations of motion. For which motion actually? They are the linear motion. Understand? So motion, which is actually a linear motion. So these are the three equations we used to study in 9th class. Even derivations also you have to learn by that time. So V means final velocity, U means initial velocity, A means acceleration, T means time, and S means what, guys? S means
Distance or
distance
displacement.
or displacement. So now, these three equations of motion under angular acceleration, if you have taken angular acceleration. So what is the symbol of angular acceleration, everybody? Angular acceleration, alpha. So when alpha remains constant, then how these equations will be replaced, modified? So we all know that velocity. So in their velocity, initial velocity V. So angular velocity. What is the angular velocity formula? Wow, symbol omega. So final velocity, angular initial velocity, acceleration, angular acceleration alpha, and time. Here t. There what will happen? There also t only. And here everybody, yes, here S means distance. There S means what? Everybody, angular distance. All of you, theta. Final angular velocity, initial angular velocity, angular acceleration, angular displacement. Now you can rewrite the equation. So what will happen? First equation, everybody. Final velocity equals to initial velocity plus AT. A means angular acceleration, T means time. Is it okay, Rudresh? Pradosh? Understanding? So that is what.
Yes,
Next, second equation, what will happen? You can take it theta, displacement, correct? So here displacement, here what? Angular displacement. So angular displacement is equals to, so what is that? In UT, U means initial velocity. So UT plus half AT square. A means what? Alpha T square. Next, third equation, final velocity is equals to initial velocity plus 2AS. A means alpha, S means theta. Mr. Understand everybody? Clear everyone? So these are the three equations of motion for what acceleration? Angular acceleration. But this alpha, angular acceleration remains what? All of you. Angular acceleration is always remains constant. So all of you remember, if A is constant, and as well as alpha, linear acceleration, angular acceleration is constant, then these all the equations are valid. So only by the time, but these all our equations are not always true. It's always not valid. And we have known yesterday we have derived what is the relationship between linear acceleration and angular acceleration. Everybody, linear acceleration or tangential acceleration is equals to, what is the formula? R into angular acceleration. Am I right or wrong? Everybody, please respond. This is the relationship between angular acceleration and linear acceleration. Now, which is always true? This is not true. Only these equations are true when acceleration is constant or angular acceleration is constant. So the equations which are always true, please remember, write it all of you. So the equations which are always correct, these equations are not always correct. For example, velocity is equals to ds by dt. This is always true. Acceleration is equals to dv by dt. This is always true. Now, there is another equation for acceleration. We have studied. Anybody can tell me? Rudreswa, Pradosh? Yes, please. So we have multiplied both numerator and denominator with the what? Everybody. So let me multiply with the ds by ds. So both numerator and denominator. So ds by dt will turns into what? Everybody. ds by dt will turns into, please respond, v. So v dv by ds. Am I right, everybody? Clear? Acceleration means v dv by ds. We have studied or not? So these equations is always true. This equation is always true. Same way, angular acceleration, sorry, angular velocity formula. What is the formula? D theta divided by dt. Angular acceleration formula, d omega divided by dt. So if I multiply both both numerator and denominator with the angular displacement, so that d theta divided by dt, what will happen, everybody? Which is equals to, please respond, omega into d omega divided by d theta. So these equations is always true. These are the valid equations which is always true. Either the body is in uniform, constant, or whatever the acceleration. So you have to follow that. These equations are which are always remains true, always correct. That is what. So make sure everything understand, clear, everybody. So linear, when the body is in constant acceleration, which is studied in 9th class, now what are the equations which are always true? You have to understand. All of you clear, Amma? For those understand? Anything doubt you can ask. Okay?
Yes, sir.
So please make it. Prince, you understand, Prince? That morning somebody called, what happened to them? I don't know. So this is what about what is complete introduction of system of particles and as well as rotational motion. So now today's class we are going to study the new one. So that is what it is torque, movement of force, and turning effect of force. So that is what is our concept. So please all of you keep a day. So we are going to see in our today's class the most important one and interesting. So that is what movement of force, torque, or we can say turning effect of force. Torque, movement of force, or turning effect of force. So that's what we are going to see that. I hope everybody is on. Still, who is missing? Mr. Rishi is there, Rohit is there, Monish. Call to give dial to them, him, anybody. Mr. Sai Karthik, you understand what we have studied till now? Clear? So, Mr. Rudreswa, anything doubt? Pradosh? Okay. So now we are going to study. Suppose if you want to make displacement, or if you want to make the velocity increases or acceleration increases or decreases. So for linear motion, we have to apply something. Anybody can tell me? For linear, if you want to make the body to displace or change the velocity or change the acceleration, we need to apply what? All of you respond. Force. Am I right or wrong? Please. Now, if you comes to the angular, or rotational, so if you want to make the angular displacement, angular velocity, angular acceleration, so you have to apply what, guys? Everybody, you have to apply the torque. Understanding? So this is only called as symbol is tau. So tau we used to called as torque. Okay. So for angular displacement, the force required to make angular displacement or angular velocity or angular acceleration is actually a torque. For linear displacement or velocity or acceleration, we are applying the force. So we all knows that from the Newton's second law, force is equals to what, guys? Mass into acceleration. So keep that in mind. So we are going to form the relation for torque and force also. So what is the relation? Like S and theta, what is the relation? Linear displacement and angular displacement. What is the relation, everybody? Linear displacement is equals to R into
R theta.
Yes. Next,
Theta.
V is equals to R omega.
R omega.
A is equals to R alpha. Then
Alpha.
F is equals to how much? That is, we have to find it. Don't think it is say. We'll find it. Okay. Before end of the class, we are going to find that. Okay. So we start now. Everybody clear? All of you?
Yes, sir.
So make sure now. How many of you know wrench? Wrencher, you know wrencher. to open the bolt or nut, or to tight the net or loose the net, we will use the wrench. Am I right, everyone? So many of you used to notice bus puncture or car puncture time, your father or you can see mechanics of wrenches. Spawners, we used to say in our local language, we will say spawner, or basically we say wrench, wrencher. You all people knows, everyone don't know? So at least while seeing the image, you might remember. So this is what we used to call as bicycle wrencher or spawner, we used to say. Do you all remember, all of you? Yes, at least this picture.
Yes, sir.
So now all of you observe very carefully. Now imagine there is a bolt here. See what is the names and all, you just have a glance. We don't have any use of it. That's fine, it is. So now you can notice it. Imagine there is a bolt here, which has been like I kept a wrencher. So to lose the bolt or tight the bolt or whatever it is. So all of you observe very carefully. So now I want to rotate it. If I want to lose it or if I want to tight it, either I want to rotate in this direction or I want to rotate in this direction. Am I right, Mr. Pradosh? Are you all agree with me? All of you? Yes. So I want to turn.
Yes, sir.
I want to turn this spawner. This actually we used to call it as a wrencher. So we want to turn this one. Either if you want to tight it in some direction, and if you want to lose it some other direction, just we want to rotate it. So the turning, the amount of turning to rotate it, the amount of turning to rotate it, that is only we used to call it as what? Torque. Remember the torque symbol is like this, you write like this. Even torque spelling, whenever you are writing torque, just make that first word itself is a symbol. What is the symbol name called as? Tau. Clear, everybody? So when you are writing torque itself, first letter represent like a tau, so that it will be easily remember the symbol. Tau or torque. So if you, how much if you are rotating to lose the nut or to tight the nut or bolt, whatever it is, you can remember. So that is only we used to call as, what is to call everybody? Torque. Now, for example, I'll ask Mr. Prados to lose this bolt, which is very tight. So Mr. Prados maybe applied the force in some angle by holding the shaft at this point. Now I'll ask Mr. Rudreswar, he hold it at this point. And I asked some other person, he applied the force by holding the shaft at this point. Now you tell me, in each case, is that applied force or the turning effect is remain same or different? Everybody. Yes, please. All of you. Please respond. Everybody. Now, you might be know bus puncture time. How many of you know bus puncture? Like bus puncture, when they are doing the bus puncture time, you can see that they will put that the wrencher size length is not sufficient. They will attach the long pipe and then they will start pushing it from the long distance. Have you seen, everybody? Please respond. All of you. Opening the tires.
Yes, sir.
Yeah. So
Yes,
why they are applying the force from the long, that the pipe which is attached it? Why can't they attach by using a closer distance? Wrenches. So I will show you the photos. You all can notice it in our thing. So just to see that now, you might be notice it. So what makes this turning effect only we used to call it as a torque. Now you can notice this photo, all of you. So what makes this person to attach this rod? Anybody can tell me? Actually, that is what we used to call it as like turning effect, which is a torque. So he will attach some kind of a rod for a long distance and he will start rotating very easily. Or you can see sometimes they'll put a long distance and they will apply the force with the legs also. Do you remember? Anybody? Girls? Roadside, you can see the puncture time, you can notice it.
yes,
Yeah. So why they are doing like that? Why can't they open with a small wrencher? So why they are, see that here applied force, applied rod is very long. You can notice it when they're puncture time. So why they are making that? Why can't they open normally? Because the required force or the turning effect to open that is greater. Do you all understand, everybody? It is not easy to open the bolt of a bus tire or something easily. So that is why they will attach a long rod and then they will start climbing it. You can notice the picture here. Have you all noticed it, everybody? Please respond, guys. All of you. So in this picture, you can see he is attaching one here and another kind of rod extended here, so that he will apply the force, the turning effect at this corner, so that it is easy to remove the bolt or tight the bolt. So That is what it is. The amount of turning, that amount of turning only we should call as what? Everyone? Yes?
Torque.
Torque.
So that force what we are applying is depends on three factors. The amount of turning, that is only called as torque, is depends on three factors. The first factor is how much force we are applying. How much force we are applying. That is what you have to remember. So that is the first factor. How much? For example, Mr. Pradosh is holded here. Let me take everybody. This is the point where he has been holded the set. And Mr. Pradosh applied 10 Newton force. Rudreswar 100. And Mr. some other X is 1000. Now, do you think that everybody is the turning effect of this wrencher is same or different? Everybody?
Different.
Same or different? Different. So, force increases. All of you observe. Force increases, torque also increases. Do you understand? That is the first factor which amount of turning depends on. Please remember, amount of turning depends on how much force they are applying. Second one, position, as I said. So Mr. Rudreswar is applying from the nut. So this is the nut we have here. From the nut, Mr. Rudreswar is applying a R1 radius. Let me take the distance, we is to say R1. And Mr. Pradosh is applying the same amount of force in R2. And some other is applying the same amount of force from the R3. Now you tell me, do you think that every case they will apply the same turning force, everybody?
No, sir. R3 more.
Even your door you can see. For example, your door is attached like this. Now, if you want to try to open your door, like pushing, so you apply the force at this point, or you are opening door by applying closer to the hinge. Where you are applying
Corners.
at the corner. Why? If you try to open your door, why can't you apply? Why open your door by applying the force here? It will take more greater force. Greater force is need to require to apply. Am I right? Everybody, will you all agree with me? Please respond.
Yes, sir.
Yes. So from the hinge point, if the R is increases, then the required force is less or more? Required force
Less.
will be less. So that is the second factor where amount of turning, that is what torque is depends on. What is that, everybody? Where we need to apply, where we need to apply. So that is what we used to say R. So if R increases, torque also increases or decreases, everybody?
Increase.
Increases. And third one, now for example, Mr. Pradosh is trying to apply the force exactly parallel to the R. All of you observe, this is R, and Mr. Pradosh is applying the force parallel to R. Do you think any kind of like he is applying the force in the same direction? Do you think that it will easy to open or tighten the bolt? Anybody? Like this, he is applying the force. Yes, Mr. Rudreswar. Imagine that you are having a bolt here and you are applying the force in this exactly perpendicular. This is what. So do you think that it is possible to rotate either clockwise or anti-clockwise?
No, sir.
No.
No, sir.
So at what angle? Either he has to rotate, apply the force in this angle, or he need to apply the force perpendicularly to the surface, or he need to apply in this angle. That is what. So what angle he need to apply? So because angle will decide the applied force also. How much we need to apply, more force or less force also will decided by the angle. Am I right, everybody? Clear? All of you? So that is what. So what angle? So these are the three factors which will decide the amount of turning. This amount of turning only what we used to call, everyone? Yes, please respond.
Torque.
Clear? So please complete this one. Till here, anything doubt, you can ask me, or else you can finish it. We will continue from here. I hope everybody understand. Brothers, clear? Yes? Yeah. So basically, if you want to tighten the bolt, we have to rotate the anti-clockwise. If you want to lose the bolt, we want to rotate the clockwise. So something, okay, let it be. Clockwise or anti-clockwise will make it either tightening or lose the bolt to remove the bolt it. So that you have to remember. So what is the factors it is affecting, everybody? Yes, please. Three factors. Force, how much force is applying, where we need to apply, and what angle we have to apply. That is very important. Are you clear, everyone? All of you? So finish it fast. Who is absent today? I want to know. Two people are absent. I'm not going to entertain whomever it is. I want progress. Aswita, understand what is torque? Amount of turning.
Yes.
So now let us make it, I will say you. Now as I said, second factor. What is the second factor, everybody? Where we need to apply, that is very important. Am I right or wrong? Means from the pivot point, actually where the wrencher is holding the bolt, that point we can say what point actually? We used to call it as what? It is a fixed point. What is that point? Pivot point.
Pivot point.
So from that point, let us imagine, for example, Pradosh, you applied a force of R1 distance. Let me take R it is now. And same venture. Let me erase this neatly so that everybody understand. So till here, you have to draw the diagram. Every time you have to draw venture. So whenever I'll make it, you can draw. Or else let me go back to this and we'll make it. So now you all should observe very carefully that from the pivot point where we are applying the force, that is what. So if I apply the force parallelly, is it possible to make the wrencher to move, turning effect, everybody? So maximum
No,
turning
sir.
effect, we have to apply always inclination. Let me take this is the wrencher. Now you can see. So now, for example, at this point, I'm applying the force. This is what the force I'm applying by holding it from the pivot point. So imagine this is the what point, everybody? Pivot point. Clear, everyone? So now, from this point, okay, from this point to this point, we used to call as R. This R is only called as movement R. What we used to call? R we used to call as movement R. So this is also one of the factor which will decides the amount of, for example, same two wrenches. So now I am applying the force from this point. All of you observe, this is applied force. Now, is it R is same, remain same, everybody? R is same? No. You understanding? So that is what? So that is only called as, what is to call everybody? Movement of. Movement of. Clear, everyone? Now, so let me take again one more thing. Applied force. Applied force always has to be what? It is not be parallel. Am I right or wrong, everybody? Clear, everyone? Parallel to the R.
Yes,
sir.
Understand? So now, if you observe very carefully, so there is a wrencher. There is a wrencher. So now, I'll ask somebody to apply the force. So they applied the force in this direction. So this is the applied force. So we can apply any direction. So means in the sense of the force is applied in this direction. Am I right or wrong? Everybody clear? Will you all agree with me? All of you? Yes, please respond. So now with the surface, it is making an angle theta, means the force is exerting in a two different directions. What is the two different directions? X components, and the next one is what component? Everybody. Yes, please. Y component. So X components here is a theta. The next component, what will happen? It will become F cos theta, and opposite one will become what? F
Sin theta.
F sin theta. Now you tell me, is it F cos theta will help in any kind of rotation of a wrencher? Anybody? Yes, please. It is parallel to the radius. Parallel to the radius. So then tell me R. Yes, please. So is it help in any kind of rotation, Pradosh? It will not help in rotation. So only what force will help in rotation? Everybody? What force will help in rotation? All of you. F sin theta. That is what? So F sin theta increases, then amount of torque also. Everybody. Amount of torque
Increases.
also increases. Now, sin theta values tell me. Sin 0 how much? Sin 0. Sin 0.
Zero.
Sin 90. Sin 90.
1.
So
1.
if theta increases, then sin theta increases, then amount of torque also, turning effect also,
Increases.
everybody increases.
Increase.
Understanding all of you? So that is what? Now, so torque is equals to, from that I can say R into F actually. So F, it is how it is present, Rudreshwar. This F is present how? Perpendicularly to the what? Perpendicularly to the what? Wrencher. So that, what is the angle? Everybody? 90. So wrencher, so I can say R into F perpendicular. So this F perpendicular only I can write what? R into F. F perpendicular means what? F
Sin it.
Sin theta.
So that is the formula for torque. So please make sure it. Anybody having any doubt, you can ask me. I hope you all understanding. So F sin theta, I can write what, guys? F sin theta means what actually it is? F perpendicular, F perpendicular. The symbol for perpendicular is this one. I hope many of you understand. Anything doubt you can ask. Clear everybody? All of you?
Sir.
Yes. Do it.
Sir, this is displacement into force or distance into force, sir.
Distance not, movement arm. Do you understand it? Movement arm.
Okay,
Movement arm. Understand Rudreswar? Clear everyone?
Yes, sir.
Yeah.
Yes, sir.
Understand everybody? Please respond. Everybody understood,
Yes,
Amma?
sir.
Yeah.
Yes,
So
sir.
please make sure Manya and Samya internet problem you have to rectify it. You cannot be like every 2 minutes leaving and coming. No use of you never understand anything. So I can write torque formula what guys? All of you. Torque is equals to moment arm into F perpendicular. Okay, Rudreswar? R means is not the radius, moment arm. From the which distance you are applying from the pivot point. That is the moment arm. Understand? Yes?
Yes, sir.
Yes, sir.
Yes, sir.
Which is parallel, F parallel. F perpendicular can create a turning effect, but F parallel, what will happen? It cannot create. F parallel cannot produce what? Everybody cannot produce the torque. Okay, so which is F parallel? F parallel. Which is F parallel? All of you. F
Cos theta.
F cos theta. So F cos theta cannot produce as the torque. That is what you have to remember. I hope everybody understand. Anything doubt? Please let me know. Please respond, guys. Everybody. Yes, Rudreswar. Understood? Yeah. So now if you observe very carefully, all of you make it. Yeah, I'm hearing initially. No problem. Somebody else, who else is leaving and coming, leaving and coming? Who is that? Internet problem? What is this? Yaar, Pradeep is there always. Rohit is not there. Okay. So now, all of you observe very carefully. So we have been found that torque is equals to what, guys? Everybody. Torque is equals to R F RF what? RF sin theta. Clear everybody? So let us select this sin theta and verify it. So what is that? Either we can say either it is torque is acting clockwise or anti-clockwise. Let us make it. Okay. And also we'll study why this F cos theta not making the torque. That is also I'm going to say you now. So let me consider there is a pivot point. Okay. All of you observe. So x-axis and as well as y-axis I'm considering. So x-axis and y-axis. This is the point I also consider as a what point? Everybody.
Pivot point.
Pivot
Pivot.
point. Okay. So now all of you observe. So there is a body. There is a body. Now the applied force is here. Observe very carefully. Applied force is here. So now you tell me. Applied force is here means. So from here to here, I will imagine that. What is that moment of arm? What is this called as everybody? From here to here, what is to call? Momentum.
Momentum.
It will represent with what? Momentum will represent
R.
with what? All of you.
R.
Yes, R.
R.
Okay. See, for explaining this rotational dynamics is extremely toughest thing. And the offline, at least we can. Online is very, very tough. Imagination is more important. So please, even small doubt you ask me. So from the pivot point, the force which we are applying, that is what we used to call as momentum R. And the applied force at a point P. This is the point we are choosing the P. Now, if you notice it here, clear everybody? So this is what is applied force. Then here the force will split into how many components? All of you. Yes, please. 2 components. So this component will become what? This will become Fs.
F cos theta.
Theta.
Understanding? And this one will become what? Perpendicularly to
F
this.
sin.
F.
Sin theta.
F sin theta.
Angle is 90 degrees. So that here it will come like this. So this is what will become what? F sin theta. Okay, all of you. So that is what. Now if you notice it here, now R, if you apply right hand thumb rule, just all of you remember right hand thumb rule, as we all knows that F cos theta, no torque will create. So let it be. Why it is, I will teach you now. So no torque will be created by the F cos theta. So why it is, just wait 2 minutes. Now you all observe here. So as we all knows that this is R and this is the F cos theta. So we are moving in a direction. So radially it is like torque direction, either it is a clockwise or anti-clockwise. Let us verify, and we all knows that. So imagine we have studied vector additions. So vector additions, we have to join what, Rudreshwar? Tail to tail always for finding the direction. Do you remember? Clear?
Yes,
So
sir.
which is acting
Yes,
along
sir.
this. Now if I have taken, so this is the radial R direction, and the force is here, it is. Now R and F. So if I am moving, so R to F, R cross F, you move your hands, right hands, please put your all 4 fingers at R axis and move your hands and tell me, your thumb is acting outwards or inwards? Your thumb is acting outwards or inwards? Move from R to F. R cross F. Your thumb is acting outwards or inwards? R cross F. Put your all 4 fingers here. Right hand.
Outward.
Check it here. Your thumb is indicating what direction, Pradosh? It is acting towards to you. Means it is outwards or inwards?
Outward.
Radially outwards. So that is the direction of torque. So torque is acting what direction? Radially outward direction. And this is a clockwise or anti-clockwise. Check it, everyone. R to F. It is a clockwise or anti-clockwise?
Anti-clockwise.
It is anti-clockwise. So angular displacement anti-clockwise. So it is anti-clockwise. So the torque is acting outwards or inwards? Everybody, it is acting. Please respond. Outwards. Clear? Yes. So now if you observe, so this is what is the direction of torque. The torque is acting outwards or inwards. If you are moving R to F, everybody, it is anti-clockwise. So anti-clockwise means it is acting what direction? Outward direction. Clear, everybody? Understand, Pradosh? Rudreshwar? Yes?
Yes, sir.
Yes.
Yeah. So you apply your right hand thumb rule. Put your 4 fingers and try to move. I am putting my screen. Exactly I kept. And I'm moving my 4 fingers from R to F. So my thumb is acting towards to me. So means it is outwards. Am I right, everybody? All of you? Yes, please. So it
Yes,
is outwards, it is acting. So outwards, it is anti-clockwise. So we are having importance also. Anti-clockwise means it's a positive or negative also. I will say you just hold it. Okay. Now, sir, why F cos theta is not producing any torque? So all of you observe, F cos theta is passing through the what? F cos theta is passing through the something. This is called as something we used to call. Anybody can tell me? Axis of what?
Rotation.
Axis of rotation. So if since F cos theta is passing through the axis of rotation, so torque produced by F cos theta, which is equals to how much, guys? All of you, please respond. Zero. Because F cos theta is parallel to R. F cos theta is parallel to R. So R is actually a what? R is actually a what? Axis of rotation. So keep it in mind. F cos theta is passes through axis of rotation. So that is why we will say, so torque produced by F cos theta is equals to how much, guys? All of you, please respond. Everybody, 0. Understanding, all of you? So that is what is about torque. So always torque, which will produce the torque? F cos theta or F sin theta? All of you? Yes?
Sin theta.
Sin theta. Okay. So that is what. Next. This torque is a vector quantity. So of course, force is a vector quantity or scalar quantity. Everybody. Force is a what quantity?
Vector quantity.
Vector quantity. Same way, the torque is also a vector quantity. So if it is a vector quantity, can you tell me the formula? Everybody? Yes, please. If it is a vector quantity, then torque is equals to what? Moment arm into F. This is what the formula. Or else we can say, this formula I can say what? Actually, it is F for perpendicular. So what I can say? For those, RF?
Sin theta.
Sin theta.
Now I will put here n cap. So I taught you types of vectors. Can anybody tell me what do you mean by n cap? Anyone?
Sir, unit vector.
Very good. That is what is expected from everybody. So n cap is a what vector, everybody? Unit vector. So what is unit vector? Verify it. Perpendicular to what? Perpendicular to what? Plane of. Understanding? R and F. So that is what is the unit vector. So I can write RF sin theta. So it is a unit vector. So that formula will become, unit vector means 1. RF sin theta is equals to torque. So that is what you have to Remember. Okay. Now, I told to prepare one tie for you. What is a tie I told you to make you, everyone? There is a tie I suggested you to make. Three-dimensional one.
X-axis.
Yes,
Z
x-axis, y-axis, and z-axis. Are you all having, everyone? Make sure, at least if not there, today you can adjust 3 pens you hold in your fingers. Okay, or else tomorrow you must make it tie with a rubber band. This whole chapter it will be useful. Okay, Pradosh? It has to be completely out. Okay. Now let me take it now. So always remember RF is a vector quantity. Tau is equals to R into F perpendicular. That's what RF sin theta n cap. N cap means unit vector. So means it is perpendicular to plane of R and F. Perpendicular to plane of R and F. So all of you verify. Let us verify that. So what is the direction of torque? It is, that is what, perpendicular to plane of R and F. Let me take a wrencher now, or else the image which is there already for us. Let me take that. So I hope everybody understanding very clearly. Am I going fast? Okay, everyone? Yes, Pradosh? So like, imagine I am applying the force at this point. This is the force which I am applying that. So this is the applied force direction. So which is acting in this way. Am I right, everybody? Clear? Applied force is in this way. Now, so from here till here, we used to call something from this point. What is that called as?
Momentum.
All of you. We used to call it as momentum. So momentum is acting in this direction. Is it okay, Rudresho? Yes?
Yes, sir.
Yeah. So which is, one is x-axis. See that this is x-axis and this is y-axis. So that the torque direction will act in what direction? So x-axis and y-axis is over. So x-axis momentum and y-axis force is applying. So that there is a third axis. That is what, perpendicular. So it is perpendicular to plane of what? Perpendicular to plane of R and as well as what? Everybody? F. So means it is acting in what direction? All of you. It is acting in
Z direction.
direction. So please remember that meeting is going to end till here you completed and we'll join back. Okay. So please make sure it. Now you move your right hand. Put your right hand thumb rule. Put your 4 fingers here. Now you move from R cross F. R cross F. Now you tell me what is the direction of torque? Clockwise? Sorry, you are moving anti-clockwise or clockwise? Anti-clockwise. So